aromatic compounds and amines. Arene/aromatic compounds containing a benzene ring. Now, I might even get rid of this flashcard because there is one kind of question I love to ask, and it's like a 6 marker, and it's compare cyclohexane 1,3,5-triene with benzene. And if you memorize those 6 points on the mark scheme, I honestly believe you can attack any kind of question. You don't even need to know any flashcards, just memorize those 6 points. So I might get rid of this one. Benzene, we know benzene is very, very stable. It's plain a molecule, and it's a ring of carbon atoms with 2 hydrogens sticking out on a flat plane. The final unpaired electron is located in the p orbital, and the p orbital sticks out above and below the plane of the ring. Now, the structure of benzene. Now, again, I would honestly just memorize the mark scheme answer. Let me try and find it right now. It's the 2024 paper 2, obviously. So yeah, literally, these are the points they want. Benzene is more stable. Entropy of hydrogen benzene is less exothermic due to delocalized electrons. Both are planar. Benzene is equal carbon-carbon bonds, whereas this has bonds of different length. Therefore, the hexagon is distorted / irregular. And there's a bunch of other mark schemes you can memorize like that. So you don't need to actually learn this. Like, honestly, I'm gonna get rid of this. Because the points they want in the mark scheme are very, very, very specific. And that's why you literally do have to memorize the mark scheme points. Arenes undergo electrophilic substitution because the benzene is a region of high electron density. And what do we know about a region of high electron density? They attract electrophiles, and therefore one of the hydrogens is substituted for an electrophile. Now, it doesn't undergo electrophilic addition, is because then the benzene ring is so stable, electrophilic addition would actually destroy the delocalized ring of electrons. 2 types of chemicals containing chemical rings, benzene rings, dyes, pharmaceuticals, and Friedel-Crafts acylation. We add an acyl group to the benzene ring. Once the acyl group is added, side chains are modified using further reactions. The electrophile in Friedel-Crafts acylation is acyl chloride, and the halogen carrier is aluminium chloride. Now, the reactants need to be heated under reflux in a mixture, non-aqueous solvent for 24 hours. Nitration is used in the manufacture of explosives / dyes. We warm benzene with concentrated nitric and sulfuric acid, and we get nitrobenzene. And sulfuric acid acts as a catalyst and helps to make the NO2 plus electrophile. 2 equations of nitration: HNO3 plus H2S4 to form H2NO3 plus H2S4 minus. Now, I'm pretty sure this paper, 2024 paper, also wanted the, what's it called, those equations that you had to memorize as well. Yeah, here it is. Do they allow these equations? So HNO3 plus H2S4 to form they actually to form H2NO3 plus HSO4 minus, and then H2NO3 plus to NO2 plus H4. Interesting. So what they want you to do is they allow you to do copy and paste both equations, or you can just memorize one instead, where the H2NO3s basically cancel out. So I would just memorize both HNO3 plus H2S4 to form H2NO3 plus, HNO3 plus H to form H2NO3 plus, which is H4 minus H2NO3 plus NO2 plus H4. Mononitration, we only want one NO2 group, and we have to keep the temperature below 55 degrees Celsius because above this temperature we get lots of substitutions. And nitration reactants manufacture dyes, pharmaceutical and explosives. Nitrile compounds can be reduced to form aromatic amines. Amine. An amine is when one or more hydrogens in ammonia is replaced with an organic group. Primary amine, one hydrogen is replaced with organic group. Secondary amine, two hydrogens replaced with organic group. Tertiary amine, three hydrogens are replaced with organic group. Quaternary ammonium ion lone pair of electrons and a nitrogen can bond with a tertiary amine. In tertiary amine, lone pair of electrons and nitrogen in a tertiary amine can bond with the fourth organic group. Quaternary ammonium salts are used as fabric cleans because the hydrocarbon tail binds to nonpolar substances, for example grease, and the cationic head dissolves in water, and the ammonium ion binds to negatively charged surfaces, therefore they are used fabric conditions. Strength of base depends on how available the nitrogen lone pair of electrons is, and the more available the lone pair, more likely the amine is to accept the H plus stronger the base. A lone pair of electron depends if it has a higher electron density. Amides contain a functional group NH2, and a carbonyl group pulls electrons away from the NH2 group, therefore amides behave differently from amines. So honestly, this topic, aromatic compounds and amines and benzene and all that, with benzene, you might be overwhelmed, but honestly, memorize that mark scheme. They love asking questions about that, like a 6 marker, compare them, or just describe structure of benzene. Memorize those key points, and as long as you memorize those points and these flashcards, and obviously the mechanisms, you should be good.